Good morning, everyone. In this session, we will discuss basic electrical safety in medical equipment, a topic that is fundamental for anyone working in the field of electromedical technology. Electrical safety is not only a technical requirement, but also a critical factor in protecting patients, healthcare professionals, and hospital facilities. Medical equipment operates in close contact with the human body, often in environments where patients are weak, unconscious, or highly vulnerable. Because of this, even a small electrical fault can have serious consequences. Unlike industrial or household devices, medical equipment must meet much higher safety standards to ensure that electrical energy does not harm the patient or the operator. To begin with, let us understand what electrical hazards are in the context of medical equipment. Electrical hazards include electric shock, leakage current, short circuits, overheating, and fire risks. In hospitals, these hazards can occur due to damaged cables, poor grounding, insulation failure, or improper use of equipment. Moist environments such as operating rooms or intensive care units can further increase the risk of electrical accidents. One of the most important concepts in electrical safety is electric shock. Electric shock occurs when electrical current passes through the human body. The severity of an electric shock depends on several factors, including the amount of current, the path it takes through the body, the duration of exposure, and the condition of the patient. In medical settings, patients may be connected directly to equipment through electrodes, probes, or catheters, which significantly increases the risk. Closely related to electric shock is the concept of leakage current. Leakage current is a small amount of unintended electrical current that flows from the device to the patient or to the ground. Although leakage current is usually very small, it can still be dangerous, especially for patients with compromised skin or invasive connections, such as cardiac catheters. Therefore, medical equipment is designed with strict limits on allowable leakage current. Another key aspect of electrical safety is grounding, also known as earthing. Grounding provides a safe path for electrical current to flow into the earth in case of a fault. Proper grounding reduces the risk of electric shock by preventing voltage from building up on the outer parts of the equipment. In hospitals, grounding systems must be carefully designed and regularly inspected to ensure their effectiveness. Faulty grounding is one of the most common causes of electrical safety incidents. In addition to grounding, electrical isolation is widely used in medical equipment. Isolation separates the electrical circuits inside the device from the patient and the power supply. This is often achieved using isolation transformers or opto-isolators. Isolation helps prevent dangerous currents from reaching the patient, even if a fault occurs inside the equipment. Many life support and monitoring devices rely heavily on isolation to maintain patient safety. Medical equipment is also classified according to its level of protection against electric shock. For example, devices may be classified as Class 1 or Class 2 equipment. Class 1 equipment relies on protective grounding, while Class 2 equipment uses double or reinforced insulation. Understanding these classifications is essential for electromedical technicians when installing and maintaining equipment. Another important concept is the classification of applied parts, such as Type B, Type BF, and Type CF. These classifications indicate how closely the applied part is connected to the patient and how strict the leakage current limits must be. Type CF equipment, which is often used for cardiac applications, has the highest safety requirements because it is directly connected to the heart. Electrical safety is not only determined by design, but also by maintenance and testing. Routine electrical safety testing is a key responsibility of electromedical personnel. These tests may include checking earth resistance, measuring leakage current, and inspecting cables and connectors. Preventive maintenance helps identify potential problems before they cause accidents or equipment failure. Human factors also play a significant role in electrical safety. Improper handling, unauthorized modifications, and lack of training can compromise the safety of medical equipment. For example, using damaged power cords or connecting devices to incorrect power sources can lead to serious hazards. Therefore, user education and adherence to standard operating procedures are essential components of hospital safety programs. Regulatory standards and guidelines provide a framework for ensuring electrical safety in medical equipment. International standards such as IEC 6060-1 define safety and performance requirements for medical electrical equipment. Hospitals and biomedical engineering departments must ensure that all equipment complies with these standards throughout its life cycle, from installation to disposal. In modern hospitals, the increasing use of networked and computerized medical devices introduces additional safety considerations. While these devices improve efficiency and data management, they also depend on stable power supplies and proper electrical infrastructure. Power failures, voltage fluctuations, and electromagnetic interference can affect device performance and safety. Backup power systems, such as uninterruptible power supplies, are therefore essential. In conclusion, basic electrical safety in medical equipment is a critical foundation for safe and effective healthcare delivery. Understanding electrical hazards, grounding, isolation, leakage current, and safety standards is essential for students of electromedical technology. As future professionals, your role will be to ensure that medical equipment operates safely, reliably, and in compliance with regulations. By prioritizing electrical safety, you contribute directly to patient protection and the overall quality of healthcare services. Thank you for your attention. I hope this session helps you develop a strong awareness of the importance of electrical safety in medical equipment. Answer the multiple choice questions based on the tape. 1. Why is electrical safety especially critical in medical equipment? Medical devices are more expensive than household devices. B. Patients are often vulnerable and in close contact with equipment. C. Hospitals use higher voltage than other buildings. D. Medical staff operate equipment continuously. 2. Which of the following is considered an electrical hazard in hospitals? Incorrect patient diagnosis. B. Software malfunction only. C. Electric shock and leakage current. D. Lack of medical staff. 3. What factor does not affect the severity of an electric shock? Amount of current. B. Duration of exposure. C. Path of current through the body. D. Color of the electrical cable. 4. What is leakage current? A. Current intentionally delivered to patients. B. A large electrical discharge during a fault. C. Unintended small electrical current flowing from equipment. D. Current stored inside batteries. 5. Why is leakage current dangerous in medical settings? It increases power consumption. B. It may affect vulnerable or invasively connected patients. C. It shortens equipment lifespan. D. It damages hospital walls. 11. What is a key responsibility of electromedical personnel regarding safety? A. Prescribing medication. B. Performing electrical safety testing. C. Diagnosing diseases. D. Approving hospital budgets. 12. Which activity is part of routine electrical safety testing? A. Updating patient records. B. Measuring earth resistance. C. Training medical students. D. Installing hospital software. 13. How can human factors compromise electrical safety? Using certified equipment. B. Following standard procedures. C. Improper handling and lack of training. D. Performing regular inspections. 14. What international standard is mentioned as regulating medical electrical equipment safety? ISO 9001. B. IEEE 802. C. IEC 60601. D. WHO guidelines. 15. Why are backup power systems important for modern medical devices? They reduce equipment size. B. They improve data encryption. C. They protect against power failures and fluctuations. D. They eliminate the need for maintenance.